would like to welcome you again to our today's web seminar, Enabling Standardized Multi-Run Assay Control. Whether you're joining us from a lab, a research facility, or a regulatory environment, the next session will provide valuable insights into standardizing your assay control processes. My name is Franziska Rakitin, and as Customer Engagement Manager at UpToData, I have the pleasure of guiding you through today's coffee talk. Our speaker today is Norbert Bittner, who is the Managing Director of UpToData and an expert for automated reporting solutions for regulated environments. UpToData specializes in automating lab processes for regulatory data management. We have established ourselves as a recognized leader in reporting solutions, particularly in the field of bioanalytics. Through ongoing dialogue with our customers, we have gained valuable insights into their quality control needs, especially regarding multi-run assay control. We understand that our clients seek solutions that not only meet the FDA requirements, but go beyond these standard regulations. We are currently expanding our portfolio to incorporate these advanced solutions, ensuring we remain closely aligned with our clients' evolving needs. Today's session will explore assay performance risks and introduce you to standardized control methods along with effective risk mitigation strategies. Please feel free to engage with us through the chat function. The chat function is marked with a question mark on the panel on the bottom. For quality reasons, this coffee talk will be recorded, but of course your questions will remain anonymous. So thank you for being here today, and let's have an informative session.
So then I think we did all that. So thanks for the introduction, Franziska, and I'm happy that you're all here today. And I just directly jump into the topic. So what I'm going to discuss today is about the risk mitigation and the risk that comes from overall assay performance in long-running studies, specifically on method to mitigate these risks and to determine if everything is that you do in your lab is compliant with the regulatory requirements and not putting your overall study into risk. Because with potential problems that might arise from not well-behaving devices or issues in the preparation methodology or other things that really put your assay performance on risk, you also risk your overall data integrity. So that's something that you really need to have in mind when you start doing your assay. Potentially, if there are things happening with your assay, you run into the risk that the data is not consistent throughout the runs you're doing in your study. So overall, if these things run undetected, you are on risk to run into regulatory problems, run into inconsistencies in acceptance criteria. There might be GXP risks and GXP violations that you might run into, and overall, with these operational risks, of course, you might also risk the overall result of the study. And if you're a CRO, that might run into more specific problems, because you're not just putting that one study in risk, you might also risk your reputation, the relationship to the sponsor you're currently working with, even within the market, within that very small industry of bioanalytical studies and bioanalytical laboratories. And of course, with the reputational risk, financial risk, directly from potential problems in the study, throughout the risk that come from the reputational risk that you might run out of contracts, might get a bad reputation in the market, people will not engage anymore with you. And then, of course, the next thing is, of course, that you might run in capacity risks directly in the study, because you might have to rerun samples, you might have to reassay samples, or might have to rerun the whole study, which then ends up in once again, financial risks, organizing things. And of course, the problem overall is, how do you explain these things to happen to you when you do not recognize that these things happen to you, only when you look at the data at the end. So what to do to really get rid of these risks? Of course, risk mitigation strategy is the per se answer. Risk quality management on a risk-based approach is the one thing. Communicating to your sponsor everything you detect, everything you see, staying in constant exchange with them, and then of course how to detect these problems, training of the people, technology to improve the consistency, and then making methods or things available, reporting available that allow you to detect these problems that may lie under the hood of processes that you run for a while already, and there are some things that run out of control. So what to do? How can we implement these controls? Standardization is, of course, one of the key elements of introducing these kind of controls. So you have to do things consistently, reliably, and compliant. That's the overall goal of it. So, but how to detect non-compliance is the main question. And there are things already in the ICH-M 10 guideline that tell you about, for example, how to monitor QC samples, how to monitor calibration standards, and having all these components, from your internal SOPs to potentially system suitability tests that you run before the study for your devices during the study. All these measures you can introduce. And I'm not from a lab, but that's the things I heard from our customers. And what I will show you today, and what I'm going to dive into the deep now, is about the data management review and data review that you measure. And that for us, this is, at least for most customers also, this is a major problem to get to these data, because when you look at how data review is done today, it's usually based on individual runs. So you look at a run, and you look what are the things that the software, the mass spec software is giving you on reliable information. And when you start thinking about the ICH-M 10 guideline, there are more things in there. There's already some trends, some methods, some descriptions in what you should monitor, what you should look at when you run your assay. And when you look at what the industry discussed, it seems that this was a hot topic 10 years ago. So there are a lot of publications around that, and I just put one table from that first paper I put here, and that's what he called a data monitoring based on scientific quality objectives. And in that paper, you have a bunch of things you should focus on, and you can focus on to really monitor what happens, what's going on in your study. And what we did basically over the last years is develop a solution, and we of course had some experience with customers. And one of the major things we know for a long time is of course the QC trend, the Q samples. So if you really want to monitor what's going on in your study, the QC samples are one of the major things you have to look at. And when you look at the ICH-M 10, look at the sections where they reference to these type of QC plots, where you look at the behavior of your 3 levels of QCs over time, over the runs. That's something that is literally encouraged to do. So it's encouraged to have these graphs in the report. but that's nothing else but a usual quality control. And of course, you could potentially determine things, or if you have a lot of outliers, if there's a trend or something that you would see. But there are a bunch of hidden things that you normally do not report, and a few I want to mention here. So we're starting with things around the calibration standards. We know that there could be a trend in the LLOQ response. So measuring and just looking at the LLOQ value of your calibration standards might identify or might point you to a potential problem with your methods or your instruments. So what you see here is a trend. It's only 10 runs, so I wouldn't emphasize that too much. But overall, I think that's how you can look at a graph and immediately see more things and more information than you potentially see in a table when you just look at the LLOQ values. Or at least you have to have a lot of experience and have seen a lot of tables to really look at these things. And there are more parameters you can look at. Of course, when it comes to the calibration standard, signal to noise ratio, if your device is giving that, would also be a good indicator for the quality of the device, how the device is really reacting to your samples. And over time, calibration curve slope trend shows potentially if there's something going on with your sensitivity, and other things like the R-square trend of the calibration curve also might show you things if there's a trend, things that are happening with your device. This might have direct influence on the R-square over the runs, so there might be a trend in there too. Another thing that is usually very complicated to really look at is the retention time consistency. First, in the run itself, to see that there is nothing happening, no drift, no shift or something happening within the run. So having a graph like it that shows you there is something, then you can objectively look at these values and can determine if there's something, if that's really relevant, or if it's just a small shift, because the retention time is in minutes. So that might be 0.1 minute. That's a different. It's up to you to really determine if that is a big issue or not. But overall, outliers and unusual patterns in here should indicate there is something you should look at. Oops. When you then look at cross-run consistency, and I took an example from the same study. So what you see here is the blue, the green, and the red line, which is the median. The green line is the median, the blue one is the upper, and the red one is the lower run time. Retention time. And overall, that should be constant. If there's a trend, that's also something you should look at, but then it should not behave like this. So there shouldn't be large differences between the min and the max. So, and there's a jump within this sample. So there's something going on in these two runs, and at least you should have a look what's going on in this run. So these are measures to look at. Monitor the Planck sample after the upper level of quantification is also an identification of something like a carryover trend. There might be problems with the washing. You might readjust things for the runs if you recognize that there is a trend in the carryover. And well, how do you recognize that? And I was just giving you here a screenshot of the application that indicates how you can get there. So we're maintaining all the data of a study within the application, and these analyses you've just seen are just a click away, so to say. What you see here is the IS response, very similar to what the FDA guidance is was telling us in 2019. So you see the runs, the sequence, the color indicate the different subjects, and you can determine what's going on here, and that's just, as mentioned, a click away from the management of the data and the management of the overall data in your study. So it's not a further burden on you when you really want to implement this kind of method. you get that as a, so to say, side effect of your data management, since the application we implemented is giving you the ability to really look at the data online in real time. Whenever you upload data, you get uploaded data into these quality review or study overview tables or views that you see on the screen. So the question then is, what is that application overall, and why did we build that in? We've learned a lot from our customers, and we know that the ultimate goal for all our customers is, of course, at the end, having a report that is compliant, that they can finalize and send out for signatures and put it into the application. But the issues lie before, because you have to identify, as soon as you have the data in your system, you have to identify what's going on with your data. And that's why we built in that control step into the application. So you have the ability to look at data that is available from your study. As soon as the data is available, you can publish it and discuss that with your sponsor. And if you're someone who will be able to join the EBF in Barcelona in November, I will do a similar talk on data review, but from a sponsor perspective. And so I'll switch gears basically, and we'll have a look at the data from a sponsor perspective and discuss the aspects, how a sponsor can effectively implement these measures on site to have control over the studies. Specifically, since ICH E6 is now taking all the sponsors into responsibility. So coming back to my compliant multi-run assay controls, so what are the factors that come into the game, where I can really have influence on? Of course, sample handling and storage is one thing. But there's all the things you already know as someone who's working in the bioanalytical lab. These are the things that you have in your control, that you might change, where you have influence on the overall compliance of your runs. What we give you is the data processing and the review process to really look at the data. So and with this said, you should of course look at automation, electronic data capturing, and integration to quality control into these workflows. So it shouldn't be something that you put extra on top. It should be something that you're doing as part of the process without really putting a lot of burden onto it, but make it a part of your process, make it part of your quality management of your SOP to look at this kind of data. And really look at the compliance of the assays, because that is the major thing that we have in mind when we talk about data reviewing. So what will be from here for the future? And of course, there are regulatory trends, and we all know that there will be an increased focus on data integrity. So the agencies will further push on implementing systems, robust data management systems for your study management. And if you really look at that, it makes complete sense, and to really enable all the emerging technologies that come to play. So having a data management system is the foundation of implementing an AI mechanism. You have to have data to train the AI or the ML model to do something like predictive maintenance. They're telling you a failure of the device or telling you misbehavior of the device even before you recognize that the device has this kind of problem. Or automated data review. Why should I sit in front of the PC? Why should I make that as part of my process? Why shouldn't I just upload the data and the AI can tell me everything looks good, or there are problems, and I can show you where these problems are. So that is something that I definitely see in range, and we can potentially also show that at the EBF meeting. And of course, all that means you either have an implemented system on site, or you finally choose to go to the cloud-based study management systems, where you really have real-time access, where you have a global access if you're a global company, where you can collaborate, where you can engage people from outside your company or can provide data to people outside of your company, have real-time visualization, as I've shown you in a moment ago, and can implement things like trend detection and decision making. So that's the things you really should think about. What I've shown you today is an implementation that we did, and give you all these functionality and all of the emerging trends. So whatever you do, you have to think about that, implementing these controls. That is something that might be worth doing if it's not a lot of burden on top. You should definitely have a systematic approach to everything you're doing in this behalf. That is, of course, discussed with your sponsor, and the sponsor should discuss it with your lab and should discuss the requirements. And at the end, of course, there's just benefits for you, because the data reliability and quality will increase. You have a higher efficiency if things are standardized and you're following the same procedure over and over again. That is reducing the risk of non-compliance. And at the end, all these things would give you, not just from a financial perspective, also from a reputation perspective, this will give you a competitive advantage in the biological market. So overall, it's worth doing it, and we strongly recommend you to think about it and go the step further. Well, that is my portion of today. If you have questions, if you have things you want to discuss, please feel free to send us an email.